Hi, welcome to clickmyproject.com. Let us see our project title is The Role of Hubness in Clustering High-Dimensional Data. The high-dimensional data arise naturally in many domains and have regularly presented a great challenge for traditional data mining techniques, both in terms of effectiveness and efficiency. We provide a new concept of using extended cluster feature vectors in order to make the algorithm scalable for very large databases. And objective functions may be defined with respect to these distance functions in order to measure the overall quality of partition. It is possible for data to continue to be very sparse in all possible projected subsets of attributes of the original data. The continuity of the process. The procedure of the feature selection has to be combined with the clustering process more closely, an effective and efficient approach to the subspace clustering problem. We propose a new approach which eliminates the problems mentioned above and enables the user to gain all the clustering information contained in high dimensional data. In this paper we take a novel perspective on the problem of clustering high dimensional data. Let us see our project flow diagram is. We can start the process. The next process is relational of hub spin-up. There exist many data points having low hubness scores, making them bad candidates for cluster centers. Such points will have low probability of being selected. So next process we have to transfer in K-means algorithm. The K-means algorithm, it is only a clustering of high dimensional data process. The high dimensional multiple rows and columns in values clustering of process nearest neighbor or node value compared in centroid point. The next process, scalability of very large databases. The scalability of very large databases, extracting in the database to loading the values in data set, save in the databases. The clustering with high dimensional data. The clustering with high dimensional data, which values nearest values on centroid point. Compare low dimensional and high dimensional data. What difference in low dimensional and high dimensional to implement in our project? We have seen what is the variation in low dimensional and high dimensional. There exist hubs which are not appendices and vice versa. Observe that maximal distance to hubs drops with iterations. So clustering of low dimensional data, it has only lower data in neighbor node in centroid point, only clustering of process. The lower value of the centroid point existing system, the clustering of process, that method we have used but didn't clustering correct values, avoiding the high dimensional losses of clustering of process, more values we are not taking that method used in the system. The high dimensional data, such clustering of process depends upon the nearest neighbor node only. So nearest neighbor node values, so which data of nearest values in the such value. So it's a clustering of process in high dimensional data. There are most real world data sets are characterized by high dimensional inherently sparse data spaces and effective and efficient approach to the subspace clustering of process. Let us see our project demo is. So exist as high density regions separate from each other by low density regions. So first of all, user select in low dimensional data sets. I have to select in high data sets. There exist hubs which are not metoids and vice versa. So observe that maximal distance to hubs drops with iterations. The cluster could exist in arbitrary oriented subspaces of low density. So two parts of separated in dataset getting in our project. First low dimensional and high dimensional we will see in our project. What difference in low dimensional and high dimensional implementation in our project we have seen. So what is variation in low dimensional and high dimensional? So to click on the extract button to load in database extracted successfully. To click on the view button. So how many data should extracted database? The data is displayed here. So to click on the file button. This data set separated in two parts, divided into methods. So to click on the split control, the first table shown in 17 data separated in data sets. So to click on the split data button. So next another data save in another table shown here. The total data sets divided into two parts because in clustering of low dimensional data to separated into very low dimensional and low dimensional. So to click on the split button. The first of all we taking centroid point in datasets. Distance 0 in centroid point we take into the process. Centroid nearest neighbor node, what type of data we check, it's a high data or low data, comparing the value of the centroid point. So to click on the clustering data buttons, so to view on the clustering data table, so it is only a very low dimensional data, so distance between the centroid point into nearest neighbor, so comparing the value of centroid point in nearest neighbor node. So for example, distance C, so we have seen the 0.5 and nearest neighbor distance D values of 0.26. It is declared in the very low dimensional secure data. The clustering of low dimensional data, it has only a lower data in neighbor node in centroid point, only clustering of process. Second method we taking into the process in low dimensional data, so centroid point in distance C is only view on the low dimensional data. So we have seen in distance C values 0.55 and distance D 0.6 and distance E 0.14. So distance C value and D value is much better than distance C value, and E value so much of less values of the distance C and distance C. So it is declared in the dimensional data. So which data is in lower than nearest which nearest data is lower than the centroid point, that data were declared in the low dimensional data. The existing system to clustering a process, that method we have used, but we didn't clustering correct values, avoiding the high dimensional data, so losses of clustering process more values, so we are not taking that method used existing system failure method of process. So to click on the next button to select on the data set, high dimensional data extracting successfully. To click on the pre-processing button, so to click on the pre-processing data button to avoid removing unwanted data. To click on the next button, data in datasets. To click on the split datasets, the splits the dataset 6 parts divided into the datasets easily with method of clustering process. To click on the pre-process of split, the whole data is dividing 6 parts in pre-processing of data's value. So to click on the next button, this method of clustering of process using in K-means algorithm. So click on the clustering 1 button, clustering of 2 button and clustering of 3 button. The clustering of values, data values 403, splitting data 67 are to used in K-means algorithm in clustering of process in only high dimensional data. The clustering of process is not taking in the centroid point which values varying the nearest neighbor node, which data's nearest values of the user data. So clustering of process into the table to save on the database. The whole data is to be calculated in high dimensional data. To click on the calculate button, to click on the view button, how many density of clustering 1 process 20 and noise value 0.552 and density of clustering 2 process in 6 and noise value 2.43 something, and density of 131 clustering of 3 process in noise value 0.57 something. So density clustering 4 process in 11 and noise value 7.42 and density of clustering 5 process in 257 and 0.79 noise values. The density of clustering 6 process in 142 and noise value 1.9, which tends to show excellent quality because it uses robust method in order to measure distance between clusters. The real world data sets in evaluate is accuracy in subspace selections. The whole clustering of process noise value is shown here. The noises process is occurred, it should be occurred in average value noise to become a clustering of process in high dimensional data. Most real world data sets are characterized by a high dimensional inherently sparse data space. An effective and efficient approach to the subspaces clustering of process. The whole clustering of process, how much of noise occur in clustering values in every clustering process, how much of distance is between the mentioned density of clustering of process shown here. Thank you.